Hello, Ryan here from RLF Vacuum Cleaners in Lake and Heath, and in today's video we're going to be having a look at this Thermoplan Black and White 3 machine. This is a machine that I picked up from a guy. All I got was it's faulty, which was very helpful. So we know there's a fault on this machine. So what we're going to do is start off with, I'm going to plug my portable appliance tester in, or pat tester in. Just going to give it a quick pat test. Make sure that there's nothing. Make sure there's nothing to give any concern when we turn it on. Now, I always tend to find a good place to start with these is a little screw in there. I don't know how the camera's going to pick this up actually, but there's a screw in there, which is good. Thinking about it. What's that? 0.12, that's pretty good. Oh, we have an insulation resistance failure of 0.85 ohms. Now, because I work on these machines quite a lot, so nothing is connected. What I mean is the heat elements and things as such won't be turned on because they're all triac controls. The machine needs to be turned on. So this is purely an issue. Obviously I don't know if this is the issue or not, but this is an issue. So, the way these machines work is they have lots of relays and triacs and lots of switches and controls in them. But nothing will be energized and nothing will work. So this is purely where the cable from the plug to the distribution point on the machine. They have like a distribution point where they distribute power. And from that distribution point from there then goes to 24 volt power supply, but I don't think that'll be the issue. It might be the issue. And then from that it goes to the power switch, which on this particular machine is turned it's turned on. So from the power switch it then goes to the control board on the side, which says I filtered for power. We've got an issue with that. But of course, not getting too technical. So say rewire or plug on it. So I'll just open this up and we'll see what's going on inside. It's not too bad. The cores are a bit crushed underneath the cable grip, but I don't think there's anything there to cause an issue as such. I'll just loosen the core grip off. We'll just turn the plug again. What we'll do is we'll turn the machine off, and then that'll narrow it down to whether it's a cable fault or a machine fault. I'll test it again. I'll press test. Get the reading. My machine has sensors, nothing's turned on, but we'll press the button anyway. Yeah. So it is an internal machine fault up to the switch. So it's past the switch. If we turn the switch back on again, do the test again. Yeah, fail again. So that's not probably not short circuit though, is it? At 0.95 we shouldn't really be energizing it. So what we'll do is we'll follow the wiring. What I'll do is I'll start stripping this machine down and I'll join you. Luckily these machines aren't too bad to work on. What we'll do is we'll drop this cover off here, just undo the key and put that there. front up. Like so. I tend to put the drawer on the top, just so it keeps it out of the way. And the side cover. Side cover, so I remove the bean hoppers. So a bit rusty on these machines, I haven't done one for a little while. You take the side panel off, you've got to take the top cover off, which is a bit of a pain in the arse. That's the way these machines work. So you undo the screw up there. Cover comes off. There's like a little on here, like a little earth stud. Luckily this one wasn't connected, but it will be connected up when we put it back together again. You can always tell how good a machine's been maintained by how many screws are missing, and we don't seem to be missing any at the moment. Usually what happens is when they get maintained, I don't know whether this is due to laziness because it makes it easier, or I just generally forget. People tend to forget to put the screws back in, and that screw has dropped down there. Gently lift. Oh no, this is where the bit where coffee beans go everywhere because they're tin off. Like so. There's another little earthing stud on there. Instantly, looks like we had some sort of milk leak. Milk, it's not very good when it mixes with electrics. There's the screw. Put the screw on the little ledge down there. So we haven't even turned the machine on, I've already found a load of issues. As well. Let's bring the camera. And across like you can see where the milk's been leaking down here. Hopefully. Let's just run on the switch. We'll try and get you in a bit closer. Stick my head in the way. That doesn't look like anything that's recently leaked. Probably just a leak that's had previously but nobody's fixed. Everything nothing looks too bad, which is usually a good sign. Might as well spin the machine around a bit. I'll have a look. Now, usually when you get a leak like this, it usually dribbles along down onto the switch. So it could be the switch that's causing an IR fault, or it could be this board here. This is like the important control board. You've got a little relay here. This is relay's part of the safety circuit, so if you pull the drawer out or take the bean hopper off or lift the command unit up, this relay then disengages and it turns the power off to the grinders and other things like that, just so you can't like run it without having it all together again. We'll go through that a little bit later. Nothing looks too bad. Yeah, nothing looks too bad because we've got coffee bean here and there. The first thing we're going to do is, well, disconnect this switch and go from there. Just in case it's the switch has gone a bit funny. You get that sometimes. Now hopefully I should have another switch I can put in its place. It looks alright. It's not the original switch they use, I think. No. So I'll grab a new one of these, put that in and see if it makes any difference. Now I don't have one of these ones like before with a waterproof cover. I just want this for testing purposes only. One, two go on the bottom, like so, and then one, two go on the top. fire it up and do another test. I don't think it'll fix it, but hopefully it should improve the numbers slightly. That switch was all sticky and gooey, so that switch was all sticky and gooey, so perhaps that is. Instantly, by changing the switch, we've got 1 mega ohm of resistance. So yeah, I don't know whether this comes up on camera, but this is actually covered in sticky goo residue. So what a sticky goo residue is, sort of giving it a slightly conductive path. And it has improved it, which is very low. Usually on a machine like this, I'd like to see sort of 20 plus mega ohms. But it could be because it's just a bit damp. I mean, it hasn't been run for, well, a couple of days, probably a week, couple of weeks, week or so. It has been quite cold, so perhaps the damp's got in there, but what I'll do is I'll quickly vacuum up all this goop. Actually looking at it, the wires do look fairly old, so we've got a dodgy wire joint somewhere, but 1 mega ohm. If we run it a little bit, I wouldn't have thought that might be the issue actually. But you never know with these machines. These machines are quite complicated and got quite a few complicated things in them. But anyway, I digress. I'll get the vacuum on, clean this up, and I'll be back when we're ready to fire it up. So we just finished vacuuming it out. I'll give it a bit of a tidy up. Now 1 mega ohm, while it's not brilliant, I reckon it could just be the machine's a bit damp. So what we'll do is we'll plug it in, we'll spin it round and see what the screen comes up with, see what errors it comes up with. Because it's usually a good place to start, so if we spin you around and drop you down, now it should come up with straight away that the bean hopper and the grams drawer isn't in. If it doesn't, something's seriously gone wrong. I'll just plug this in like here. Ooh, get a nice close up of my face. So we got it on. Oh, do you see that? Oh, I'm going to do it again. So straight away, it's firing up. It's not tripping out. So this means either we've got a dodgy screen, or more commonly, the screens run on 24 volt. We're not getting a stable 24 volt, or something's pulling the 24 volt rail down. Close up my face. So it's packing up before it clicks. When you turn this machine on, there's a little water inlet solenoid in there. Oops, scroll down. Just in here, there's a water inlet solenoid. I don't know if you heard it, but when it did actually stay on for a few seconds, you hear the water inlet solenoid click. So either we've got a dodgy screen, well, no, we had a dodgy screen, and then it's still far up, wouldn't it? I'm just sort of mentally running through how these machines work. If I find a diagram of how these things work, I might include it in the video. But so the screen's got nothing to do with it. I reckon we've got a 24 volt issue. Now how are we going to get to the 20? Because the 24 volt power supply is on this side. Now if we've got the cover off, we might be able to probe the 24 volt. Now we'll do, grab a screwdriver. I'm going to take the cover off this side. Fair enough. And the panel on this side doesn't come off very often, so it's probably going to be stuck. Ooh, more coffee beans. What I'll do is I'll bring the camera around. You can have a look. I'll just stop it here. I'll just take it off the tripod. You can see all the coffee beans stuck down here. Now this is the 24-volt power supply module. Down here, this is the water inlet valve I'm talking about. When you first fire it up, this inlet valve fires up. So it could be that this is pulling the 24-volt rail down, because this is the first thing to activate. The first thing we'll do is we'll have a look over this power supply. Don't know where this is coming up, but you can probably see better than I can. It doesn't look too bad in there. Nothing looks burnt or anything. And usually when these fail, burn out, they usually trip. So, there's your output rails. Run down there, so your wires come out on this plug here. So we've got here, we've got your two positives and two negatives. But only one of them is used. There's only the middle two used. So if you get the multimeter on there, probe it, see what happens. Now because this is going to be such an awkward one to film, I've got the camera on the tripod pointing at my MHL multimeter because it's got a really nice big display. I'm going to turn it on, and obviously, you know, usual rubbish applies about safety and everything, but I've worked on these machines before. I know what's dangerous and what's not dangerous to touch, so I'll be reasonably safe. Always be careful. Right, it doesn't stand right now. So what we're going to do is we're going to power it up. Now we have currently disconnected the 24 volt, so nothing should happen. But when we probe, hopefully we should get a nice steady 24 volt. So we turn that on. Again, getting 24 volts, bang on. I'm getting a nice steady 24 volts. So the issue, let's turn this off quickly. So the issue is with the machine somewhere. Something is pulling down the 24 volt rail. I've managed to get my probes in somewhere else, and I reckon they should hopefully. So you can see when it's loaded up, don't know how it's coming on the camera, but we're getting 8.6, 8.7 volts. So something's dragging the 24 volt rail down. Now what's pulling it down is a different question, because most of the control system on this is 24 volt. All the valves, the solenoids, your brushless DC motors, the screen, you've got the control board on the side, all these three-way valves on the side. They're all 24 volt. So, when you get to situations like this, it's all about breaking faults down. So we'll start off with what's the most likely to cause an issue on the 24 volt rail. Probably going to be the solenoid valve on the side, because they often break. Disconnected. That's been disconnected, so that makes no difference. So the solenoid on the valve's alright. Now this is really got to be incredibly careful, because the machine is actually switched on even though it's not doing anything. Could it be the piston motor? Because they've got piston motor in here, they're notorious for failing. But it's not actually getting anywhere, is it? Usually when piston motor or something fails, the machine fires up. So this is an issue straight away on startup. We'll just turn it off quickly. So an issue that starts up straight away. I reckon it's either going to be a control board issue, or wiring issue. It could be the screen. What's the easiest way to do it? I don't really want to be pissing about the control boards, do we? Because that's a right fat. It'll strip literally the whole machine down. What about we disconnect wire for the screen? That would probably be the easiest way. And just tilt it up and zoom out a bit. Yeah, so they think, oh, so something's dragging the 24 volt valve down straight away. Now wiring is going to be a pain in the ass because there's a lot of wiring in this machine. But I think we just have to start with big chunks and break it down. So if we've done the inlet valve, to be fair, usually when the inlet valves go, they usually melt, it's quite obvious. I suppose the easiest way would be to diagnose the next biggest steps. I reckon it's probably the screen. Now, official protocol should be you pull the modules out. Am I brave enough? Yeah, sod it. The screen is a bit of a pain in the arse, so they've got this little cover on the back, which is a pain in the arse to do, but I reckon it's probably the screen. Because if it's the modules, it's at least far up and it gives some sort of error. So here we are. Getting this cover off ain't too bad. Getting back on there's a pain in the ass. It's a lot worse on site because you don't have as much room. You can't usually get around to the sides of them very good. Pretty bad. I'm looking at the back of the screen. Nothing looks too bad on there really. So we'll just unplug it. So that's the screen disconnected. You can see the connector wire there. Yeah. We'll try again. So we'll drop you down. That's a better view. We'll zoom in a bit. So we'll plug it in. I'll turn it on. Hey! That's better. We're getting a higher voltage, so obviously that's got something to do with it. You can see the machine is cycling on and off. Obviously when that solenoid valve kicks in, it is actually dropping the voltage slightly, but we'll try disconnecting it. Getting 13 volts. So something's still pulling the 24 volt rail down. So I'll just turn it off. So we're making improvements. We've got I've got higher voltage, but still not high enough. It's still resetting while trying to start. Obviously, a solenoid valve. I don't think it is a solenoid valve. I think we're going to have to start removing these modules. So remove these modules. And this is a bit of a pain in the arse. It's going to take some time. So we'll put what we need to go inside down there. Remove that. And luckily these modules are quite easy to do with the cover off. Just pull this pipe off there. We'll lift it up a bit. You got like these pipes and they connect to little connectors on the side. They're just push fit. Now because we've got the cover off, it makes it jolly easy. So we'll just tuck them pipes in there so they're not flapping around and getting in the way. Now these machines are brilliant to work on because these modules literally just pull out like that. So this here is the mechanical module. What's 24 volt on this one is this motor here is 24 volt, and then you got a actually quite heavy these modules, and then on the front you've got a little air valve solenoid, that's 24 volt as well. So we'll put this to one side. Again with these, got this pipe here that goes into a quick disconnect, and then this here is your waste or overflow. This is the overflow from like the pressure relief valve, and the valves for the hot water and cleaning. This one doesn't have the cleaner one, no. The hot water one, I don't know what it's come up on camera, but the hot water valve is this one here. When that closes, they have like a little pressure relief valve inside, and it dumps the water down and it goes to drain. Good idea, because obviously when water, it's not water, you get like a little water hammer effect, which will break something, because these run at about 10 bar pressure. So pull this off like so, tuck that out of the way. This just unscrews. Pull it out. To be fair, nothing looks too bad, does it? And things on 24 volt on this. You've got these water pump and milk pump. That's milk pump that's been changed recently. Yeah, I think it looks alright. And then pumps don't look burnt. Usually I'm just the connector got hot. Then you've got all these. Then you've got all these 24 volt, got two solenoids there, and then you've got a solenoid down here. And then you've got your hot water valve here. You've got your cleaning water, your tea water, and then you've got like your flow meter here. So there's lots of 24 volt things on here, and by pulling these modules out and firing it up, see what happens. Now I have a funny feeling that I don't think there's anything wrong with these modules. I think it's probably the wiring on the machine, and if not, if that's the case, we're going to be in for a long night. Might actually go home. So that's all the modules. The machine looks quite empty and bare now, all the side covers off and everything. We'll leave these valves on the side. Leave all these valves on the side disconnected or connected up, because if not, we can unplug. We can easily unplug them and plug them back in. So we'll drop the top down, and we'll bring in the multimeter, which is still got connected up. Like so. And we'll fire the machine up quickly. We're getting better. We're getting 15 volts. So if we disconnect that solenoid valve, which is a bit that's clicking, we're still only getting 14.7 volts. Disconnect that. Yeah, we're still. Ooh. Still only getting 14.7 volts. So the 24 volt rail is still being dragged down. So we've still got an issue, which is a pain in the arse, because this is going to be, I bet it's going to be wiring, but the problem with wiring is you've got to eliminate every eventuality, because there's no point ordering a very expensive wire loom and spending half a day stripping it all out and rebuilding it all and putting all the wires back in, if it turns out to be a valve, which is easy to change and considerably cheaper. So the only things we have, if we just spin this around, left connected, we've got the main board on the back, but I don't think that's an issue. As well, just unplug all these valves, just in case one of them's causing an issue. Yeah, nothing looks too bad, does it? So we've got all of them unplugged. Bring in the meter again and fire it up. We're still getting that voltage drop. Still not getting 24 volt. All that stuff disconnected. So that's all the valves and everything disconnected. All we've got connected is that board there. This control board here. I don't think that'll be the issue. And then we've got the main control board. To be fair, the main control boards don't really go wrong. And boards don't usually go wrong. Still only getting 14.8 volts, 7.8 volts. So we'll disconnect that board. Turn it off quickly. Yeah, so as we disconnect that board there provides the input to drive. These here are to drive the grinder motor. So this is all grinder motor input, and then this here is all the connections for all the auxiliary stuff, because you've got your auto couplers there, and they provide power to these triacs. So I'll just disconnect that. Try again. And again, we're getting slightly higher voltage. Well, no, not actually. We're back down to 14 volts again. So, where do we start? I suppose we better take the cover off the back and have a look at the main board, I suppose. We're still only getting 14 volts. So something's obviously dropping the voltage. Dropping 10 volts. So something must be getting warm. We'll turn it off and keep going. So when I was going to film this video, I thought it was going to be nice and simple, but this one's going to be one of the more complicated faults. So I'll spin it round. The good news is this is a genuine real-world fault finding. The reason why I bought this machine was because somebody else has had a go at fixing it before and given up. And I started to see why. This is a wiring fault. We've then got to strip all this wiring loom out and try and find the issue. It's just going to be a pain in the arse. So at the back of the machine here, we try and readjust it. This big shield at the back is a cover for the main circuit board. I'll just remove that. There's no black sooty skid marks on there, which is a good sign. I went to a couple of machines and the machine's completely dead, and a big black skid mark, sooty skid mark where something's shorted out and blown out. Now the best way would be to unplug these one by one and see what the hell happens. That then will then eliminate most of the wiring of the machine. So, what should we start off with? We'll start off with the big one at the top. The big one at the top is the control for the, well, see someone's been in here before and broke the little plastic studs off. Thank you very much. These have little plastic studs that hold the thing on. And there's also a little connector. Little locking tab for this is missing as well. Probably the bit that fell off. So we'll undo the connectors for the brushless or the milk pump motors and water pump motors. They use brushless DC, which is basically 3-phase DC, low voltage DC. So we will make sure everything's looking good, nothing's damaged. Yeah, so we'll turn this on. What are we getting? No different. So it's not brushless DC. So it's not the wiring for brushless DC. We'll turn it off again. We'll plug back in brushless DC. In fact, no, we'll leave it unconnected actually. So we'll put it back, because if we don't, we'll forget where the plugs go. No, I know the people are all different, but doesn't matter. What should we do with the next one? Coffee unit. Coffee unit. So that coffee unit will be the top bit. Yeah, I reckon it will be, won't it? Yeah, coffee unit will be this top tray with the mechanical stuff in it. So we'll fire it up again. We're getting no different. Still getting 15 volt, 15, 14.7. That's not that one, so it's not a coffee unit. We'll reconnect that one up. So that's coffee unit connected. The next one down is your DC power in. Next one down is hydraulic unit, which is basically your heaters and your water, like your boiler, your bulk heating, your valves for your heating and everything. So we'll plug it back in again. I'll plug that solenoid back in, just so. Still no different. So we've still got the fault. So it's not on hydraulic unit. And we'll plug hydraulic unit back in. Ooh. That's hydraulic unit plugged in. Do the next one down, which is, I do believe, at least with the valves on the side. The job to see the rating, because when you get to the ones on the bottom, they put the rating in funny places. So plug that back in. Instantly, still no different. So it's not that. We'll plug that one back in. So it's not that one. What else we got? This one here is chassis. The chassis will be, I believe the chassis is for the safety sensors and stuff like that. It's a job to know. I haven't worked on this for a little while. So we'll unplug the chassis, turn it back on. You can see, well, it's still no different. Not actually getting anything on it. Ah, chassis must be that solenoid valve because it's not clicking anymore. The chassis must be that solenoid valve. Quite a few wires on there, so it's not the chassis one. Put that down, so I'll put that one back on. And we've got one here for steam module. This machine doesn't have a steam module, but we'll unplug it anyway, just in case. I do believe this is just a shorting link. So unplug the steam. No, I don't think it's going to be the steam because that's literally just a shorting link to say it's no, it's not the steam one. It's not getting no better. So I'll turn that one off. So what we got left? We've got power board. And that's it. I do believe that probably is actually. Oh no, we've got that one there. Whatever that one here is. The power board is the thing on the side. I can't remember the name of it. Because, yeah, it does all the power stuff. And that one there. I've unplugged the power board. Well, still no better. So it's not the power board. So what else have we got? We put the power board one back in. Here. What that was there? Benson, got this connector here. What does it say on there? What's this connector here do? Oh yeah, that connector there. The last one I'm going to unplug is for the auxiliary connector down here. So this is when you have, like, for this particular machine, you've got like your tablet sensors and detection sensors. So you have 2 read sensors on each of these. One to say when there's a tablet in there, one to say when it's closed and in place. And this one here has also got the fridge, so that'll be the fridge connection as well. I don't think it's going to be this, but it only leaves one left, which is the connector for the screen. And I can instantly say it's no better. So hopefully on the last one now. So we'll connect that back in. That's for like all your auxiliaries. Hopefully we'll unplug the screen and it'll work. Hopefully. Because if it doesn't, we're in big doo-doo. We've got a new control board. So that one there is the last cable to be unplugged. I don't think there's any more cables in there. Turn it on. Oh! Don't know how well you can see this. Where's that dropping? It did go up to 24 volts. It did shoot up to 24 volts. But it's not anymore. Why is it not dropping? Do that again. Yeah, it's still no better, is it? This is an interesting one, this is. Very interesting. One, no other option. We just have to unplug everything and see what the hell happens. So I'm going to have to take a few pictures, so I'll have to stop the camera, unplug everything, and we'll join me back when I've got it all done, or all disconnected. So I've got everything, all the wires disconnected off the control board, other than the 24 volt wire power going in. So we've got power going in, but nothing coming out, so it's just that control board. So what we'll do is we'll fire it up, see what happens. Instantly, you can see it's now higher. Oh, it's dropping now, 15 volts. So with nothing connected, we're still getting the voltage drop to 15 volts. So somewhere on that board, we got a fault with that board. I'll just double check something quickly. We will disconnect the 24 volt from the board. I'll just probe the end of that wire and make sure we're not getting some sort of issue with that wire. As long as we're getting 24 volts in that wire, that's 24 volts going into the board. Probes connected into the wire. Yeah, they're coming at that wire. We've got 23.9 volts. So it's that control board. So we've got a control board issue, and that is handily they put the part number on the board. That one there is a 116.099. So I have to see if we can get hold of a 116.0099 on board. See how much they are. But we'll take the board out first and we'll give it a look over. Make sure we can't see anything obviously wrong. I can't see anything from here, but then again I'm not right up next to it. So we'll disconnect that quickly. But anyway, now that's all disconnected, I should have my special tool for undoing them. Because I've got these plastic like clips. Have I got my special tool? Yes, I have. I got it right here in front of me. The special tool for undoing them little clips is a Bic pen. I didn't know that. So if you want to do these little plastic clips and you piss them out with pliers and stuff, just get an old Bic pen. Just push that over the end. Push that over. Push it off. I probably should get the camera in a better angle actually. So here we have my big pen, and you just push it over a little plastic slot, like so. And comes off like so. Ooh. There we are. That's the control board out. And I'm looking at this and I can't see anything wrong with it. Nothing on the back, oh that's all lovely and clean. We're dropping 10 volts, something must be getting jolly warm. Nothing feels warm. I always conformal coat of everything, so testing is a nightmare. I don't know whether it comes up on camera, but there's absolutely hundreds of these tiny little tracks on there. So I suppose what's most likeliest to have failed? Could be a capacitor, probably a diode. This is really a job for another day. It's getting a bit late in the day to start investigating things like this. Ultimately, realistically, I want to go to a test bench with 24 volt supply and probably worth sticking a thermal imaging camera over it. See if we can see any particular thing getting warm. Although we've got this capacitor here, don't know how it's coming on camera, we've got this capacitor here, it's slightly skew-if. It looks like it was originally soldered. Usually all the capacitors, they all sit like nice and flat on the board. This one here is a bit skew-if, so I wonder if that capacitor's packed up. But it doesn't look like it's blown the bottom off. But anyway, I'm probably going to end the video for here. I'll just zoom out and say thank you for joining me along with my diagnosis trip with this black and white 3 machine. I managed to diagnose there's an issue with this board. Whether I make a subsequent video about diagnosing this board and eventually fixing this machine, or probably more likely this machine was brought to me because nobody else could fix it. But anyway, we've now got, I'd say, probably a 60% thing that's issue with this board. Where we can fix this board is a different issue. Again, this machine isn't going to work unless the issue is fixed. So currently at the moment, it's scrap. It's not really worth anything. All it's worth maybe a few spare parts. Screen's probably worth a bit, and you've got a few valves and the power supply. But yeah. So I'm just going to thank you very much for watching. I hope you had a nice time. Probably been boring as hell. It's going to be a long video. But yeah, this is the diagnostic journey you have to make sometimes when working on these machines. If I was to skip things and miss things, I could have ordered, you know, £1,000 board. I don't know how much these boards are, but I'm guessing they're going to be hundreds, possibly thousands of pounds, because these are £10,000 plus machines. Now, if I just said, well, it's a board issue, and ordered a new board, and I fit in the new board, and it didn't work, you're going to look a right tit. A right tit, and I mean a proper right tit, and then you'll be in no different position you are now. So you may have the machine all stripped out. It's inconvenient, it takes time, but I haven't ordered anything in the hope that I'm fixing it. I'm just looking at this board now and I can't see anything wrong with this board. I mean, nothing smells. So yeah, fault finding is an art form. Sometimes it's quick, sometimes it takes like 5 minutes. You know, you walk up to the machine, oh it's that, let's fix it. But not everything is simple in life, unfortunately. That's why they pay people with the big dollars. If it was simple, then everyone would do it. So yeah, thank you very much for watching. I'll see you again sometime.